Hi guys, today we're going to talk about translations on the coordinate plane. So in our notes, we're on pages 3 and 4, and I would probably write this along as I write it down as well. So we just talked about the 4 basic types of transformations, how we can move figures in math. We can slide them, which is what we're going to talk about today. Or we can reflect them or flip them over things. We can turn them and rotate them, and then we can dilate, which means to make them either bigger or smaller. So first, we're just going to slide things and just move them with translations. So a translation moves every point of a figure in the same direction and the same distance. Okay, so a translation can move a figure right or left. And or it could also move things up or down. Okay. Translations are also thought of as slides. So we're just sliding or moving it to transform it. Okay. So first we're just going to slide them and kind of see if we can come up with some rules of how translations work. So it says to translate this figure 5 units to the left and 2 units down. Record the coordinates of the pre-image and image in the table. So what I did for you is we have triangle ABC, okay? And I already wrote what their coordinates were. A is 2, 4, B is 6, 7, and C is 7, 3. So the way we notate this, or how we write this, is we write the vertice, and then we would write their ordered pair, the coordinate that makes it. Now, I want you to keep in mind, ordered pairs, we've been doing slope for a while, but ordered pairs are just x, comma, y. So we move on the x-axis, and then we move on the y-axis. Okay, so this is not slope. This has nothing to do with slope. Okay, so what I'm going to first do, and if you like colors, you might want to get a color out, okay? But what I'm going to do is I'm going to start with A. Okay, and I'm going to go with the way it's telling me to move. So it tells me to go 5 units to the left. So I'm going to move 5 units to the left, and then I'm going to move 2 units down. Okay, and when I did that, I'm going to plot my new point, and I'm going to label it A prime. Okay, now I'm going to write this as an ordered pair. X first, -3, 2. Now I'm going to do the same thing with B. B is right here. I'm going to move 5 units to the left and 2 units down. And then I plot my new point, and I have B prime. I've transformed B into B prime. Okay. As an ordered pair, it would be 1, 5. Okay. Finally, we have C. Okay, we're going to follow the same directions. We're going to go to the right, to the left 5, and then we're going to go down 2. And I'm going to label this as C prime. Okay. So C prime is 2, 1. That's where it's located at. Okay. Finally, I am going to connect these 3 vertices into a pretty new triangle. Okay, so go ahead and draw that out. Okay. So, what it says, there's a rule to all of this stuff, and so I want you guys to see if you can notice any patterns. I'm not going to look at A to A prime because we have negative numbers, okay? But I can kind of look at B and B prime, and I can kind of see how the x coordinates and the y coordinates show that transformation. Okay, so first let's look at, we'll write B prime, we'll write B, which is 6, 7, and then we'll write B prime underneath it, which is 1, 5. Okay. So what I notice is if I look at just the pattern of it, okay, here are my x coordinates and here are my y coordinates. my x-coordinates went down 5. Okay? My y-coordinates went down 2. Okay? So let's check and see if maybe the C and C prime did the same thing. So if I start at 7, which is C, the x-coordinate for C, and I go down 5, I'm at 2. Okay? And then if I'm at 3, and I go down 2, I'm at 1. So the pattern kind of looks like I had to go to the left. So when I think of left, I should think of going back, so subtracting. Okay? When I think of going down, I also think of subtracting as well. So a way to write this algebraically, which is something new, okay, is we take our original coordinate, x, okay, and we need to go to the left 5. So to go left 5, we need to go back 5. So we're going to subtract 5. Okay. Then we have our y-coordinates. And to get to our new transformed picture, we have to go down 2. And the picture shows us that we have to actually go down 2. So to show down 2, we're going to subtract 2. Okay. All right, for number 2, we have triangle DEF. Again, I wrote the coordinates for you. D is -7, -4. E is -4, 1. And F is -3, -5. Okay. The transformations it asks us to do this time is to translate the figure 4 units to the right and 3 units up. So we're going to start with D. We're going to go 4 units to the right, and then we're going to go 3 units up. Okay, and then I'm going to label it D prime. Okay, D prime is located at -3, -1. Okay. Now we're going to do E. So E needs to go to the right 4 and up 3. So E prime is right here. As an ordered pair, that would be 0, 4. And then for F, we're going to go 4 units to the right, 3 units up. Label it F prime. As an ordered pair, that would be 1, -2. Now, you obviously do not have to draw the actual way we moved or anything like that. That's just kind of my way of helping me kind of visualize it. But you do not have to do that. If you just want to draw and visualize what we did and then the new picture, D prime, E prime, F prime, you can obviously do that. Okay, so now what we're going to do is we're going to look and see if we notice any patterns, okay? So it said to go 4 units to the right. When I think of going to the right, I kind of think of like adding, okay? Going to the right, getting bigger, right? If I think of 3 units up, I also think of going up and getting bigger. So we're going to kind of see if we can kind of figure this out. So I'm going to pick any ordered pairs. There's negatives in all of them, so really it doesn't matter. It's not like one's going to be better than the other. I'm going to pick E, -4, 1, and E prime, 0, 4. Again, we have our x coordinates and our y coordinates. Okay. Now, how we transform to go from -4 to 0 is we would have to go up 4. Okay. To go from 1 to 4, we would have to go up 3. Okay. And if we look, right shows we got to make like an idea that it'd probably be going up, and that is right. We had to go up 4 on our x coordinates. Okay. To go up 3, our y coordinates had to go up 3. So algebraically, the way we could write this is to find our new transform figure, we take our x coordinate, our D, E, and F. Okay, we take our x coordinate, and we have to add 4 to it to go to the right. Okay. Then algebraically, we have to take our y coordinates in D, E, and F, and to transform it to go up 3, we would have to add 3 to it. So algebraically, this is how we can write these. All right, let's go ahead and go to page 4. Okay, for numbers 3 and 4, again, I also wrote the coordinates for the original ones. Okay, and I wrote GHIJ, KLMN. So just take a second and write those coordinates down for you so it'll be a little bit less work. Okay, so it says record the coordinates of the pre-image and the image in the table below. So we have GHIJ, we have a rectangle, and it looks like it just slid over to create G prime, H prime, I prime, and J prime. So the first thing we're going to do, it asks us, is just to write the coordinates. So I'm going to do G prime, H prime, I prime, and J prime. Okay. So I want you guys just to try writing these coordinates down. Okay. G prime is -5, 3. -5, -3, excuse me. H prime is -5, +3. I prime is -2, 3. And J prime is -2, -3. Okay, so it says to write a verbal description of the translation. So I'm going to show you guys 2 different ways. Okay, again, we have it visually, so we might as well use it visually. So you can pick any of these vertices. I'm just going to pick G and G prime. So what I'm going to do is I'm going to ask myself, what movements did we make to get from G to G prime? Okay, so it looks like I have to go to the left 2, 4, 6, 7. 2, 4, 6, 7. Okay, and then it looks like I need to go up 4. Again, I don't want this to write this as a slope. This is completely different than slope. The only thing we're talking about now is how it transformed. So the verbal description of this translation is we went to the left 7 for each vertice, and then we also had to go up 4. Okay. Another way that you could do this would be just to look at the before and the after of the vertices. Okay, to go from 2 to -5, we would have to go down 7. So as long as we know that X means the movement left or right, we could show that. So the algebraic representation would be taking our X coordinates and subtracting 7. Okay, I could check it by doing it over and over again. 2 minus 7 is -5. 5 minus 7 is -2. 5 minus 7 is -2. So I'm taking all of my X coordinates and I'm subtracting 7. Okay. Then we need to figure out our movement up and down. So we're at -7 and we have to get to -3. So it gets closer to 0 and it looks like it goes up by 4. So we're taking our Y coordinates and we are adding 4 to it. I can also see that visually by us going up 4. Okay. -1 plus 4 is 3. -1 plus 4 is 3. -7 plus 4 is -3. So all of these coordinates show the same algebraic representation. All right, finally it says, what do you notice about the line segments in the pre-image and the image? Do they change size? Okay, so we're just going to kind of just visualize it and look at it. So I'm going to look at IH. Okay, so I can see that it's 1, 2, 3 rectangles long. Okay, when I look at the transformed picture, I prime, H prime, it's also 3 lines or 3 boxes long as well. So what do you notice about the line segments? It looks like they stay the same. Do they change size? No, they are congruent. All right. For this last one, I'm going to kind of let you guys try this a little bit. I want you guys to go ahead and label K prime, L prime, M prime, whoopsie, and N prime. Okay. K prime, we have 2, negative 7. L prime, we have 7, negative 7. M prime, we have 7, negative 2. N prime, we have 2, negative 2. Okay, so if you missed any of those, just go ahead and erase it and just rewrite those. Okay, for the verbal description, you can pick any of these vertices, but I want you guys to write what you guys think the verbal description is. Okay, so you can pick any of these. Okay, I'm going to go from K to K prime. Looks like I need to go to the right 2, 4, 6, 8, 9. Then I need to go down 2, 4, 6, 8, 9. Okay. So the verbal description looks like I need to go to the right 9 and down 9. Okay. Okay, go ahead and try to write the algebraic representation for this. Okay. Algebraically, to show to the right 9, to go right 9, we need to take our x coordinates and add 9 to it. For our y coordinates, we have to go down 9. So to go from 2 to negative 7, we would have to go down 9. Okay, what do you notice about the angle measures in the pre-image and the image? So I want you guys just to look at the angles. And so when we're looking at angles, we're looking at like something like right here. You see how that's kind of just a 90-degree angle. Okay, so I'm going to find its corresponding angle, so n prime. Okay, does that size change? No, they do not change. Okay. So what we are going to do is tomorrow we're going to start off with these 3 problems. You can try them if you'd like, or if you'd rather just wait, that is fine. Okay, but we're going to go ahead and I'm going to give you the answers now since we're doing it in class. So describe the translation. So we have M to M prime. Okay, and if you want, you can get a piece of graph paper out and plot 12-7. 12-7 would be right here. I'm just making that up. And M prime would be -1, 14. Okay, so it's asking what movements did it make? So it looks like it went to the left and it went up, but we need to figure out how much. So instead of using a piece of graph paper, we could also just find the change between them. So to go from 12 to -1, I can visually see that it does go left. But if we find the difference between them, so that would be down 13, okay? I can visually see that it goes to the left 13, okay? Then I can see that it goes up. Okay? To figure out how much we go up, we look at our y coordinates. To go from 7 to 14, looks like it has to go up 7. So the translation would be left 13 and up 7. Okay, for this next one, again, you could use a piece of graph paper. N is -6, -8. And N prime is -5, 2. Okay, so we need to figure out the movement, the translation that occurred. So I'm going to look at the x coordinates. To go from -6 to -5, looks like we need to go up 1. So visually, the x coordinates went to the right 1. Okay. Then we have movement on the y values. To go from -8 to +2, it has to go to 0. So it has to go up 8. Then it has to go up 2 more. So that's up 10. So up to 0 and then up 2 more. So it's up 10. So the total translation would be of movement right 1 and up 10. Okay, so the last thing you guys are going to do is try this one. Okay. We have -3, 6. and -9, -1. So to go from -3 to -9, sorry, this is O and this is O prime. Looks like it has to go back to the left, so it needs to go to the left 6. And then to go from 6 to -1 has to go down a lot. It has to go down to 0 and then has to go down one more. So it has to go down a total of 7. So the total transformation would be left 6 and down 7. All right, today there is some Delta math practice that we will practice as a class.